Virginia, and 19 years at North Shore Blue Scope Steel over here in Delta, Ohio. So today I'm going to talk about technology, how the steel plants use tools, machines, and processes to meet your needs. What do you think your needs are with steel? What do you think? Exactly, yeah, the chairs you sit on, the cars in your driveway.
Garages.
Yeah, like maybe some of the doors and stuff, panels, yeah.
The support beams.
Yep, exactly, support beams in buildings. And just in your house, your washer, your dryer, your stove, your refrigerator, all those things use some steel. All right, so let's talk about, before we talk about how steel is made, I want to make sure you guys understand some concepts that are involved in steel making. But let's start with this. What's this made out of?
Wood.
Wood. Where's that come from?
Trees.
Okay, I don't see any branches or leaves. There they go. Good job, help me out. There. Huh? I watch the news and stuff.
Oh, you do? Oh.
Okay.
Oh.
Anyway.
They went to other stuff because since the branches can't exactly be used for that,
Yep.
they go to other things that need even long stuff, or maybe even they went to some kids who want to sword fight with them.
Yeah. Okay. Well, I can tell you that the trees that you see out there go through a process. So the process is we're removing the things we don't want. We don't want the leaves, we don't want the branches, and we don't want the bark. So that is removed. And then you have nothing but the center of the tree. That goes to like a sawmill and gets cut into boards, which we can use for furniture. That's a pretty easy process to remove what we don't want. Anybody know where steel originally comes from, where it starts out? Johnny, don't want to talk to me today. Okay.
It starts out underground.
Underground. Very good.
It's rock, and then it gets melted up.
Were you here at the first presentation? That's pretty good. Yeah.
It's melted up, and then it lets it dry, and whatever shape you mold it into is what shape the steel is going to be.
Pretty good. I think you've done some of your research before I did my talk. Very good. So steel comes from, I'm going to say, a technical term and an everyday term. So the technical term is iron ore. And as Johnny was saying, the everyday word is like a rock. And if you went and looked at an iron ore pile, to you it would look like reddish rocks and dirt. Just a big pile of reddish rocks and dirt. Okay. So if you hear me say iron ore, that means like a reddish pile of rocks and dirt. And if I do use a term that I don't write on there for technical term, because I've been talking about this stuff for 26 years, just stop me for a minute and say, hey, I don't know what that term means. Can you write it on the board for the everyday term? Okay, so the main ingredient in steel is iron. And we need to remove the iron from this iron ore. The problem is the iron ore is made up of a lot more things than just iron. It's also made up of oxides. And oxides are oxygen combined with other things, again, including iron. So it's oxygen mixed with things. Stuff we call it. We don't want that. So I'll give you an example of how mixed that is. If you have different colors of Play-Doh and then you squish them all together, you can't separate out the red again and the blue again very easy. That's the problem we have with the iron ore. All this stuff, the iron is intermixed with all this stuff into one solid rock. And we need a way to separate it. So the way we do that, I'm going to talk about, have you ever heard of this word? Density? What's that? Does anyone know what it means?
It's like how packed together something is or how loose it is.
Very good.
Solid stuff has more density than gases or
Very, very good. You're absolutely right. So density plays a big role in how we're going to separate the iron out of the iron ore. So just to give you some examples, and we're going to learn a little bit more about this concept, we have two items here. We've got a golf ball and a ping pong ball. Okay? So if I would put these both into a graduated cylinder with water, they would take up about the same amount of volume. But the difference is, this has a lot more, so density is mass divided by volume. Which one of these two do you think has more density? Anybody know which one of these two has more density? You can just call it out.
Golf
All right. If I take this golf ball and I throw it out into a pond, what happens? Sinks, right. If I throw this golf ball in the pond, what's going to happen? Because the golf ball is more than the water, so it'll sink. And the ping pong ball is less dense than the water, so it'll float. All right, so we got that. So the next thing I wanted to talk about is I have a container of water with just a drop of blue food coloring in it. And I have some cooking oil that you use for salad dressing or cooking cakes. The oil is less dense than the water, okay? So if I pour this water in on the oil, what do you think is going to happen? You can just say it.
The
water
dense.
The one that's more dense will go to the bottom. Which one's more dense? Did I say?
Water.
Right. So even though I'm pouring this right on top of the oil, it'll mix for a minute because I'm pushing it down in there. We give it a little bit of time and let it sit here. You'll start to see that the oil is coming back to the top because it is less dense than the water. Understanding this is very important to understand how steel is made. So make sure everybody is paying attention. I have one more question. Don't answer it right away. For 1 second. If I bring in a ton of feathers and I bring in a ton of bricks, which one is heavier? Who thinks a ton of bricks is heavier? Nope. Okay, and so you didn't raise your hand. Do you think a ton of feathers are heavier?
No, because a ton is 2,000 pounds. 2,000 pounds is 2,000 pounds, no matter what it's, no matter how.
So what do you think? They're the what?
They're equal.
Equal, exactly. Because if I bring a ton of bricks in here, it's probably just going to take up the back corner by Mrs. Jones' desk, and that's it. If I bring in a ton of feathers, it might fill the whole entire room. They both weigh a ton, but the feathers have a less volume than the bricks. So that's why it's going to take up more space. Okay, I think if we got all that in our head, we're going to talk about iron ore now. So luckily for us, if we melt the iron ore, so we're going to melt it, so we're going to melt these rocks, they're going to separate. So the parts we don't want, the oxides, so now we're going to call the technical term, once we melt this, it's going to be called slag, and the everyday term is going to be liquid dirt. Okay.
Dun, dun, dun.
I know, I did that before. So this, we're going to call this the bottom part. Once we melt these rocks, this is going to be the liquid iron at the bottom, because the liquid iron is more dense than the liquid oxides, the dirt, the junk. All this stuff comes to the top. The question is, how do we melt it? What's the hottest way, or what do you think we can melt it with? What do you think, Johnny?
They just put it over fire.
Fire. Well, that's a good point, but the problem is a fire is about 1,100 degrees. But we need well over 2,000 degrees to melt these rocks. What do you think?
Molten lava.
That would be great, except I don't have a volcano nearby. If I had a volcano, we could use that heat. But we don't have a volcano near Delta, Ohio. Okay?
A thing that's kind of like an oven, but it's not.
Okay. What do you think happens in, you're right. What do you think happens in that oven? What do you think?
Well, it's like a kiln, kind of. Like
The kiln? So what's happening in there? What's producing all that heat?
the heat's like coming in, it stays in there because the lid's locked on tight.
Yeah.
And it like
Okay. Well, what I'm talking about here is, did you ever make a volcano with baking soda and vinegar?
Yeah.
Anybody? You've done that? So what's that called when it starts bubbling up? That's a chemical reaction. Well, we have some chemical reactions that we can do that produce a lot of heat, enough heat to melt rocks. So the chemical reaction we're going to talk about happens in what Reese was saying, or somebody back there was saying a big oven. So I'm going to draw this big oven. Okay? I'm going to call it a big oven. But the technical term is a blast furnace. That's what this is called. All right, blast furnace. You know what, I didn't tell any of the other classes this, but the reason why it's called a blast furnace, I just was thinking about this, is when we open this up to get the liquid iron out of there, they actually blast it with some dynamite. They blast it open each time and they break it shut. So, so we're going to have a chemical reaction happening in here. So we have something called Coke. I'm just going to put it in the technical term. Even though you hear of Coke, it's not the Coke you drink or anything like that. This is a form of carbon, which I'll also put in the technical term. I don't think you use that term every day. Carbon. It comes from coal being processed. You know what coal is. They don't want me to say this, but it's from Santa putting it in your stocking. Everybody knows what the little black rocks are. They're like, oh, don't say it.
Did Morgan and Salem get that in their stocking last year?
Yes, they got in their stocking last year.
I
You got it too?
I got some real gold.
Yeah, that's great. Free coal, you know, coal is very expensive actually.
Cool if you compress it like a lot. I don't know how much you have to compress it. It makes nice.
Yes, I know. I heard that in the last class. So we need this coke. This is coal that's gone through a process where you drive out all the tar and the gases and stuff that's in there. But so you know what it is. It's kind of like this black. It still kind of looks like black rocks, and that is put in the bottom of this blast furnace. So we have some coke down here. And then we blow in some really hot preheated air. So some hot air is going in there. Once that goes in there, the coke starts to form a chemical reaction. It starts to burn. Really hot gases come off of this, very hot. And in the top, then we're dumping in the iron ore. And we also dump in some lime. So we'll talk about what the lime is. So the lime, I don't know if anyone's familiar with the farmers. They put lime on their fields sometimes. It's like a white powder. There's lime that's processed over in Woodville, Ohio, and in Huron, Ohio. If you ever get an opportunity to go visit one of those, or at least drive by it, it's white as far as you can see. It's just like a white, big white area. And I used to go visit some of those plants once in a while. And I've been there on occasion where I was lucky enough to see how they mine this lime is they put dynamite along in the hills, and then everybody gets way far away and they blast it, and a whole section of the hill falls down, and then trucks go in and load the lime up in big chunks. It gets crushed and then sized into smaller pieces, and that's what's happening just right over here in Woodville, Ohio. Okay, so the purpose of this lime, one of the things it does, it also floats to the top when it's liquid here. So down here, once this reaction starts burning and it produces all this heat, the iron ore will melt. So these rocks are now melting, and the lime, which comes in like rocks too, it's also melting. And all our junk, our oxides, our liquid dirt, everything, all this junk slag, this is all the same thing. It's just intermixed words. It's all coming to the top because it's less dense than the liquid iron. And the lime, what it does, it acts like a sponge. It helps hold it there. So that's why we put the lime in. It just soaks up this stuff and likes to hold it so we can have a clean iron, liquid iron down below. So then when this is all done, this is opened up, and this liquid iron goes into what they call a torpedo car. So a torpedo car is kind of shaped like this. It's probably as big as a railroad car. It's got a hole on the top, and the liquid iron goes into this. The only problem now that we have, we've removed all the junk, pretty much all the junk, but now we got this coke mixed in with it. So now we have liquid iron. Liquid iron, can you see that? Iron plus carbon or coke. So we got almost what we want. We want just liquid iron by itself, but now it's mixed with carbon. So this torpedo car goes to another big oven. And this next big oven is called, it's not bigger than that. It's actually smaller. I need to draw it that big. Oh, and I forgot to mention, this is 130 feet tall. So to put that in reference, is your house is probably, most houses maybe are about 20 feet tall. So this is about 6 times as tall as your house, this big oven for this furnace. So the next place that it goes to is called a basic oxygen furnace. So we dump in this liquid iron plus the carbon still in there. We put some lime in also, just because you can't perfectly separate this. If I would try right now and separate it and dump it off, I'm still going to have a little bit of oil left. So you want to continually try to trap all the junk that you can. So we throw some more lime in here again as a sponge to soak up anything that didn't clear out from the first process. We try to separate as much as we can because the liquid slag goes off in one area and the liquid iron goes off in another. We drain it out of both ends to try to separate the two. So here, in the basic oxygen furnace, high-powered oxygen is blown in here and reacts with carbon. So the oxygen plus the carbon make carbon monoxide. Have you ever heard of that? Do you have a carbon monoxide detector in your house? If your furnace doesn't burn exactly right, it produces carbon monoxide, and that's very dangerous to breathe. So that's what's happening here, is carbon monoxide is formed, and then comes out in bubbles. It becomes a gas, the oxygen blows in, reacts with the carbon that's in there, and forms that carbon monoxide gas. As that leaves the furnace, it doesn't stay carbon monoxide very long. It changes over to carbon dioxide, which the trees breathe and the plants breathe. Okay, so then after this is all done, and this becomes and now, once all the carbon is removed, we no longer call it liquid iron. In the steel industry, at this point, it is called liquid steel. Okay, so we dump the lime out, the slag, and then we take the liquid steel and we put it in a big bucket. So then we take it to the next machine. So this machine is kind of hard, it's kind of even hard to draw or to visualize. But if you've ever made popsicles and you dump some Kool-Aid into like a container, like a mold, that's what happens. This is what we do with this, is we're going to dump this kind of into a mold. So if we look at it from the side, here's the big bucket up here. This is liquid steel. This is the mold. The mold starts to cool it, so the outer surface starts to become solid. And it starts to move down through here. We keep it moving in a single long strand. It's just like if you rolled up some dough and you kept pulling it and making it longer and longer and longer. It's one strand, one long piece. So it starts to come down through here. It starts to become more and more solid. And water starts to spray in here once it becomes fairly solid. Water starts to spray to cool it faster. So as it comes down through this strand, then by the time it makes it down here, it's solid. Now the mill that I used to work at, we used to cut these into slabs. And the slabs are just like big rectangles of steel. And then they would use them later to reheat. So if they reheated them later, then they could roll them. So if you roll cookie dough and you have a roller pin, but you can't let the sides get any wider. It can only get longer. So when you roll it, it'll get longer and longer and longer. And that's what happens here, is this piece gets rolled longer and longer and longer. And when it's done, it gets so long, and then they roll it up at the end. And that final product is called a coil. Have you guys seen these on trucks? This is called a steel coil. And this is the final product of the steel mill that I worked at before. It is also the final product at North Star Steel that I worked at in the second place, but we made these very differently than the first place.
My dad works at Swan Welding, so like the people in the shop there like weld steel.
He's built stuff for our end of the mill, and we can talk about that too. So at North Star doesn't start from scratch. This is from, so I describe the process from scratch, where you're mining something out of the ground. Oh, I forgot to mention the mining equipment for this is so huge. It looks like a big Ferris wheel with buckets on the end, and it just spins, and it's just digging into the ground like that. It's pretty neat. A lot of the equipment that are used in the steel industry is very big. And what North Star does is it recycles steel. So one of the things it uses, if this coil, when you unwrap it again, and you take some pieces of it, we're going to look at it in this direction. You can cut out pieces of it just like you would cookies out of dough. And they'll use those pieces to make parts for cars or whatever they need to with that. So if you roll it out and you cut out your cookies and you put them off to the side, you have that leftover dough. So at home, what you would do is roll that dough back up and roll it out and use it again. It's not that simple here. You just can't roll this back up and use it again. We need to remelt it. So that's what North Star does. So that's one of the things that melts is this leftover, I'll just call it leftover cookie dough. That's one of the things that comes back in big trucks. Now the next thing, did you have a question? No. Okay. The next thing that North Star does is they buy shredded cars. So old cars that nobody uses anymore that they take to the junkyard, they take that and they shred it into thousands of different pieces. Normally we would like them to remove the seats and the windows and all those things like that, because those are junk that we don't want. It's like the oxides kind of over here. Now in the steel industry, we call that fluff, because that's kind of just what it looks like. It's like fluffy sponges or something in there once it all gets shredded up. So the fluff is the car junk. Car junk that's shredded, that's not metal. Also, there's other things that we don't want, and then it's technically metal. We don't want the copper wires. That causes a lot of problem with the final coils.
When the basic oxygen furnace, you worked with those, right?
I did at my first job.
And didn't when they dump them into the big bucket, didn't they have to like have everybody get away because
Yes.
it's so hot?
Yep, we'll talk about that. After I'm done, I'll talk about safety.
Does this process just work with steel, or does it work with slightly stronger or weaker metals?
That's a good question. I don't know. I don't really, I've been to like other plants where they have little furnaces because they'll coat some of the coils with this and they melt like aluminum and different things like that. But I'm not really totally familiar with the processes to answer your question. Anybody else? Oh, where was I? The fluff. Okay, so this fluff and car junk that's shredded that's not metal, this is the stuff that we want them to minimize when they send us in scrap. This type of scrap is cheaper. This is the most expensive scrap you can buy. We buy back the stuff. In fact, we buy back some of our own steel. We sell coils to someone, they stamp on parts, then they sell this back to us. We're actually buying our own steel back to melt again. And then shredded cars. And then the other main scrap type that we purchase is big metal beams. So most likely when they tear this place down and you move to the new school, there's going to be a lot of big metal beams that hold up the next floor and stuff like that. Any construction sites where they're tearing down old buildings, a lot of those metal beams wind up, some of them wind up in North Star. So what they do is scrap yards come in and they buy those materials and then they take them to their scrap yard, and then North Star buys stuff from the scrap yards. So that's how we might even get some steel beams that are in your school building, and we might be melting at North Star in a few years. Okay, so the other thing is at North Star, we need to melt the scrap. So it's a different way, a whole different system than this. They also have a big oven, but their big oven is heated by electricity. And there's three things that the everyday term that we actually use in the steel mill is sticks. They call these 3 sticks that come down. And they are made from the graphite, like your center of your pencil, and electricity passes through them, and like lightning bolts come out the end. And it's 7,000 degrees Fahrenheit. That's what a lightning bolt is, coming out there to melt the scrap. It's very loud. It sounds like firecrackers going off. So the guys all need to wear a lot of hearing protection. It's so loud that you can feel it just vibrating through your body. Just the sound of it is extremely loud. So the other thing that comes off is the same thing at North Star, the CO2 gas. And when I haven't worked there for now like about a year and a half, but when I was there, they were talking with the Nature Fresh across the road to send this over, because remember I said the plants breathe this stuff, to send this in a pipeline over to them to help them grow their plants across the street. I think that's one of the reasons why they chose that area to build that Nature Fresh. Okay, so then it goes through the exact same process at North Star, where you drain out the liquid steel. It goes through the caster. The only difference is at North Star it's a lot more efficient. They do not make these slabs. It goes straight from the caster into the roller, and it rolls up to a coil at the end. Okay, so the next thing I want to talk about is safety. So like you were mentioning that you were next to a very hot furnace. A lot of these guys have to wear, when they get near the furnace, like a big silver suit. They kind of look like space suits or something, like they're going to the moon. And big, huge gloves and a face shield to protect from the radiant heat. They wear hard hats to protect if something falls. Piece of scrap sometimes can get hung up on parts of the furnace and fall. They wear hearing protection plus earmuffs over that. And the earmuffs now, they did a long time ago, the earmuffs have radios in them so they can communicate with each other, because the safety has improved over the years, over the last 20 years there. So when I first started working there, they didn't have to wear all this stuff. But some of the equipment is still exactly the same. So I'll give you an example of the engineering design process. So that we had a problem with, the guys would use this controller that they pull back and forth to move a big piece of equipment. And the problem was, once we forced them to wear all this big bulky stuff, big bulky gloves, they couldn't grab onto the controller very easily. And sometimes their hand could even slip off. It was just because their glove was so big and bulky. And that's dangerous when you're moving a big piece of equipment. You need to be able to hold on to the stick that controls the big piece of equipment that's moving. So we did some research. We conducted some research and talked to them about, there's things we could think of, like getting a smaller glove that still protects your hand just as much. Moving the controller, we talked about moving it to their foot or a foot pedal, all kind of different things. So when we did our brainstorming session, we had to bring other guys in that actually do the job rather than a few engineers sitting around talking about it. It's best to include everybody when we do brainstorming, especially the people that do the job. So we bring a couple guys in that have done the job to get their suggestions. And then we wanted to build a little prototype. We came up with the idea of, instead of using the hand controller, to push on it with your foot. So whenever you push on it with your foot, you can see what you're doing, and you don't have to use this big bulky glove. So they tried it out for a while. We tested it. The guys evaluated it. And then if there was anything they wanted a little bit changed in it, then we would go back and redesign it, but it worked well the first time. So then we communicate to the other departments like maintenance, and we said, we need to keep this pedal safe, because we don't want a piece of scrap falling on it and landing on it and moving a piece of equipment with nobody there. So we had to build a safe box around it to protect it. So all these things have come about because there was a change. Something that used to work a long time ago no longer works. So we had to go through the engineering design process to do that. Okay, and I have one more engineering design process I want to talk about that I use on my job. Okay, so we used to have these big tanker trucks that came in, and they would bring carbon. So I'm going to try to draw a tanker truck. I don't know how many wheels they have. But this tanker truck was full of carbon that I needed. And the carbon that I needed to be about the size of rocks. So it looked like lumps of coal. So this stuff costs more money than the little fines or the little pieces of carbon they also sold for a different purpose. So this cost less money. This was the exact same stuff. All it was the little pieces that had broken off with time with this. They would keep that in a separate pile. They would keep this in a different pile. So what they would try to do is they would try to sneak some of this in their truck. This truck should have been full with all the big stuff. But they would try to sneak in some of this little stuff. Sometimes they'd be as crazy as just practically fill the whole truck with that little stuff. And the reason why it was very difficult to catch them, because there was more than one supplier bringing this material in. So we didn't know who was doing it. So they had, long time ago, they had these hatches on top of the truck and a ladder so you could get on top of the truck. So what I used to do was I'd climb up that ladder and I could reach that first hatch, open it up and peek down in there. Well then, I found out, I decided, this is 20 years ago, before I thought about being safe all the time. Now I would never do anything like this. But I crawled across there, and I'm like 10 feet off the ground. And I opened up this hatch, and I opened up this hatch. And this hatch was full of all the junk, because they never expected me to crawl across there and check them. They were doing everything they could to try to send us stuff to make extra money. Because this stuff didn't cost a lot of money, this stuff cost a lot of money. So they were charging us this amount of money, but sending us this. So I had to use the engineering design process to come up with a better way when I realized, this isn't smart to do. It's not worth killing myself and falling off a truck to see if these guys are sending us junk. Now what this material does, so this truck is solid, you can't see into it, and it gets pumped into a silo through a pipe. So here's the silo. So it's all enclosed everywhere. It's very difficult to monitor what they are sending us because everything's enclosed. So what I found by conducting some research was I found in our computer system, no one even really knew about it because, when the plant was originally built by some people that came, nobody really communicated everything that was available to you. So when I conducted some research, looked through the system, I found in the system the silo levels were in the computer system somewhere. So I could see the silo level was at 50%, and when this guy was done unloading, maybe it went up to 70%. So I started realizing I could find out how much he raised the silo by. Now, if he sent the good stuff, this is how much the silo should be raised by. But since the other stuff is what? I don't know what it is. It's less what? Or more. I'm sorry, more what? More dense. It's more dense. So even though it weighs the same amount, they would always bring about 23 tons. Even though it would weigh the same amount, the trucks get weighed on the way in and on the way out. Even though it weighed the same amount, this guy that would send a bunch of this stuff, he would maybe only raise the silo level by 10%. And that's how I was able to catch them without having to drive up on the truck. I started to watch the levels that they were raising it by. So what I did was I contacted all the suppliers and told them, this particular day, we're going to test your truck several times and stop it. Because the only way to see what's in here is you have to stop without climbing on top. If the guy starts pumping it into the silo, you have to make him stop and dump the stuff out of his hose. And he has to depressurize his truck. It takes like 10 or 15 minutes at a time. And if I would have to test it several times throughout there, that might waste almost an hour of his time. And he has to be to a next place to do his next load. And he's not very happy wanting to waste his time with me shutting this down. So I told him the one day you warn your drivers we're going to do that. And of course, that would be the day that they would send their best stuff. But what I was doing, I was calculating the data point for where they sent their best stuff in. I would see how much they would raise the silo by. Then after I did that, I told them what I did. And I said, from now on, if I don't catch you raising your silo by this level when you bring your material, then we know that you're bringing us the junk. So that's a way that I could test and evaluate, and then I communicated the results to all the suppliers that this is the standard that I'm going to hold you to. And that's about the end of what I have to say.
Do you guys have questions for Mrs. Finley? Johnny?
So they were trying to cheat everybody out of a bunch of money for less than it's really worth.
Yeah.
Kind of like some companies do.
Exactly. In fact, that happens with the scrap. It comes in on the truck, so like this, and you can only see the top of the truck. They'll open up they'll take their tarp off the top of their truck, and sometimes they'll put their really nice stuff on top. And then down below, it's the junk. But you can't see it when you're inspecting the truck. The girls that watch the trucks come in, they can't see it. So we try, and now North Star has hired 2 people in the last couple of weeks that are going to inspect the trucks, watch them as they dump. Because when they lift up and they dump all this stuff, maybe you can see some of this junk here after it dumps. And this is like the good or whatever. And you can try to catch them doing these things. Yeah, there's a lot of stuff that goes on. There's some guys that are the good guys, but
My dad in electrical engineering,
and where's he working?
surface commission,
Where at?
surface commission.
Surface commissions? Did you have a question? Billy?
My dad used to work at North Star.
Oh yeah, that's right, I knew your dad.
What if they kept selling the good stuff, part good stuff and part junk? What if they run out of junk and then somebody else wants to buy junk, but they run out of it?
That's a good question. That would be their problem, and yeah, I don't know. That's a good question. They could probably make the junk by beating up some of the other stuff if they had to.
My dad actually works at
Oh, he does? Oh, cool. Yeah. They're running now, or they're making stuff there? Okay.